In this video, we want to look at graphing a rational function. There's some steps that go into graphing a rational function. The first thing that we want to do is we want to factor. We want to factor the numerator and the denominator. That will allow us to see the domain, which, as we remember in our last video, is going to be the denominator setting equal to 0. Then remember, when we actually solve it, we say it's not equal to 0, and then we write our domain in interval notation. Remember, after things have been factored, we want to see if we can cancel. The reason we want to do this is because, remember, whatever's left over in the denominator is going to be that vertical asymptote here that we'll see in just a little bit. So that's the reason that we want to cancel off. Then the next thing that we want to do is we want to find the x and the y intercept. Remembering that we're going to plug in a 0 for either the x or the y and solve. That vertical asymptote is, remember, when we set whatever's left in the denominator after we've canceled off, we set it equal to 0. That'll give us our vertical asymptote. And then the last thing that we want to do is we want to find the horizontal asymptote or oblique asymptote, depending on what it is. Remember, we had those 3 cases that we were kind of memorizing, where we're comparing the highest exponent of the numerator and the highest exponent of the denominator. And in those cases, the numerator exponent could be greater than, it could be equal to, or it could be less than the denominator. Okay? So just a little bit review on those things. So the only real new thing that we want to do is we want to transfer all of this onto a graph now. So we're still finding all the elements that we did in chapter 5.2, but now we want to transfer it onto a graph. So the domain is not really going to be graphed. We'll see it in the graph, but we're not going to actually go do anything. So the first 2 steps, I don't really need to actually graph those. The third step is when I'll actually do something on the graph. Remember that an x-intercept is going to be a point on the x-axis, and the y-intercept is going to be a point on the y-axis. So those values that we found, we're going to go put those as ordered pairs. We're going to put a dot on those axes. Okay. A vertical asymptote also will appear on the graph, whether we have 1, 2, 3, however many asymptotes we have. And it's going to end up being a vertical dashed line on our graph. So if x is equal to 4 for our vertical asymptote, I go over to the x value of 4 and I draw a vertical dashed line on 4. Our horizontal asymptote would be just as we did the vertical asymptote. It's going to be a horizontal dashed line. Any asymptote is going to be drawn with a dashed line. An oblique asymptote, depending on what it is, will depend on how we graph it, right? Remember, when we have the line y equals ax plus b, I'm going to have a slope, and I'm going to have a y-intercept. So we might see all of those things, okay? So let's see if we can do some. So first, let's go through and find our elements. So the first thing that we're going to do to find all of these things, I'm going to go through, I'm going to factor the numerator and the denominator. So the factoring, the first one, that's just a difference of perfect squares. So 2x plus 1 and 2x minus 1. Our denominator is going to factor to be a 2x, an x. Let's see, a 1 and a 1. I'm going to add those. All right, so I've factored now. So the domain is going to be the denominator. So we've got that 2x plus 1. We're going to set that equal to 0. And we've got our x plus 1 is going to get set equal to 0. I'm going to solve each one of these. So I'll move my 1, divide by my 2. So x is going to equal negative 1/2. Subtract my 1 here. So x is going to equal negative 1. Now remember, when we solve it, we say that it's equal. But when we answer, the domain is actually going to exclude. So saying that it cannot be those values. So my domain is actually going to be negative infinity to negative 1. Remember, we're going in numerical order here. Union negative 1 to negative 1/2. Union negative 1/2 to infinity. Right? So the next step that we want to do is we want to find those intercepts. This is one of those where we want to make sure that we have factored and canceled. We saw in the last video that it's a little bit easier to look at a reduced form when we're finding those intercepts. So I noticed you saw I canceled off the 2x plus 1. Oh, let me go back. I said I did it, but I actually did not do it. Kind of did the wrong thing there. Okay. So I want to cancel off the 2x plus 1 from both because they have a common factor. So those get canceled off. So what that means is that my actual equation is just this part, 2x minus 1 over x plus 1. Okay, so that's actually what I'm going to use when I find my intercepts. So to find my intercepts, remember my x-intercept, I'm going to set my equation equal to 0 because I'm plugging in 0 for y. So I'm going to use my new equation, 2x minus 1 over x plus 1. The first step to solve, remember I'm going to multiply by the denominator, which is going to cancel here. So I get 0 equals 2x minus 1. I'm just going to keep solving it here. Plus my 1, divide by my 2. So x is equal to 1/2. Okay, I can write that as an ordered pair. So my x-intercept is 1/2, comma 0. My y-intercept, I'm going to plug in a 0 for my x this time. So I have y equals 2 times 0 minus 1. Again, I'm going back to my reduced form. When I plug in a 0, I get y equals negative 1 over 1. So y is equal to negative 1. I have the point 0, negative 1. It's important at this point that I want to write it as an ordered pair or a point because when I go to graph it, I want to know the difference between what is a point and what is a line when I go draw it. Okay. So the next thing I'm going to do is my vertical asymptote. My vertical asymptote, after we have canceled, we're going to look at the denominator and whatever is left over in that denominator. So what's left over in my denominator here is going to be my x plus 1. That gets set equal to 0. So it is whatever is left over in this denominator is going to solve to be the vertical asymptote. Okay. So finish solving it here. I'm going to subtract my 1. So x is going to equal a negative 1. And I'm going to leave that as an x equals because it's actually a line. Oh, sorry, I didn't box those last intercepts in. Okay. When I go to find my horizontal asymptote or that oblique asymptote, I'm going to go all the way back to the very beginning and I'm going to compare those highest exponents. I see that they are equal. I've got an x squared over an x squared. So remembering those cases that we had, when my exponents are equal, I'm going to take the number in front. So my horizontal asymptote is going to be y equals 4 over 2, which will reduce to be a 2. So y equals 2 is that horizontal asymptote. Okay, so now let's go through and actually do the graphing because right now really all this is chapter 5.2. So what's making it unique is actually being able to translate this into a graph. So the first thing I'm going to do, I'm just going to start dotting it up, put my asymptotes on there and see what we've got. So when I first go through, remember my x and my y-intercepts, those are going to be dots. So I'm going to go to 1/2 on the x-axis. On the y-axis, I'm going to go at negative 1. I'm going to draw a vertical dashed line at negative 1. I'm going to draw a horizontal dashed line at 2. back to the very beginning and we said, okay, well, an asymptote, when we first described it in chapter 5.2, was a value that I'm going to approach, but I'm never going to cross. So I'm going to get really, really close. So if I just kind of play connect the dots here, and I start connecting the dots between these two intercepts, I know that I'm going to have to approach this horizontal asymptote at 2. So I'm going to get really close, but I can never cross. So I'm actually going to, as I'm increasing, I'm actually going off to the right. So I'm just going to keep that going, and it's going to kind of level off going over to the right. Okay. So thinking about the same thing that we did, I want to connect these two together. And as I'm going down, I notice that I'm going to get really, really close to this vertical asymptote, but I can never be that asymptote. Okay. So I want to have that same idea on the other side of this asymptote, vertical and horizontal. But I don't have any points. So what I'm going to need to do is I'm going to need to find some points. Now, I already know, looking back at my domain, I already know what's going to happen between -1 to infinity, right? So I've already got all this green graph going here from -1 all the way off to infinity. So what I care about is what's happening over here on the left-hand side from -infinity. So I've already got these things checked off. I care about what's happening from -infinity to -1. So I'm just going to pick a random point. Let's say I decide to pick, well, how about we pick -2? So I'm going to pick the x value of a -2. I'm just going to say, I wonder what's happening in -2. Just like we did in the very beginning of this class, if I want to know what a y value is and I know the x, I'm just going to go plug it in. So I'm going to plug in this -2. And I'm just going to see what value that I get. So plugging in my -2 here, I'm going to end up getting 15 on the top and 3 on the bottom. Well, 15 divided by 3 is 5. So I noticed that when I picked -2, I got 5. So my ordered pair would be -2, 5. So now I've got another point, -2, 5. I can continue doing this however many times. Me personally, I only need 2 points to be able to connect the dots, just like I did on the last one. So I'm going to pick another point. Let's say, just for fun, that we go ahead and pick -3. So I'm going to pick -3. I'm going to do the same thing. I'm going to plug it in. Plugging in -3, I'm going to get 35 over 10, which that can reduce to 7 over 5. So, I mean, it's not a beautiful number, but enough to where I can understand what's happening. So that's going to be, what is that? 2.4. All right, so I can go graph that. I'm at -3 and 2.4. So I go -3, 2.4. That's enough for me to say, hey, let me connect these dots. As I'm increasing, I'm getting really close to that vertical asymptote. And as I connect these kind of going to the left, I'm going to level off horizontally. And that's how I'm going to graph one of these rational functions. Okay, so let's look at another example here. So I'm going to start, I can factor, the only thing I can really factor here is with a GCF, and it's not really doing much for me. But I've at least attempted to factor. Some of them won't even factor at all, and that's perfectly fine. So my domain is going to take that denominator, set it equal to 0, and I solve it. I get 2x equals negative 3 divided by my 2. So x is equal to negative 3 over 2. But remember, domain, I'm going to exclude that value. So my answer is actually going to go from negative infinity to negative 3 over 2, and then union negative 3 over 2 to infinity. All right? Now let's talk about our intercepts. I try to, but I cannot reduce this because there's no factor that they have in common. So I can just use my regular equation to find my x-intercept. I'm going to set the equation equal to 0 because that's plugging in the y to be 0. So since there was nothing that I could factor and cross off, I'm just going to use my original equation for all of this. I see a fraction, so I'm going to multiply by that denominator, which is going to make us cancel. Remember, 0 times anything is just 0. So I get 0 equals 3x plus 3. And let's go solving here. So I get x to equal negative 1. Now remember, it's an ordered pair. So I want to say negative 1 comma 0. My y-intercept, I'm going to take and plug in a 0 for the x's. 3 times 0 plus 3 over 2 times 0 plus 3. So I end up getting 3 over 3, which is 1. So again, as an ordered pair. So I've got my x-intercept here, negative 1, 0. My y-intercept is 0, 1. So now I for sure have at least 2 points on that graph. All right, so now I'm going to go back horizontal asymptote or oblique asymptote. I'm going to go back and I'm going to compare the exponents. I notice I've got an x divided by an x. So the exponents are equal. So that means I'm going to take the numbers in front. So I'm going to have a horizontal asymptote at y equals 3 over 2. I can go ahead and, if I want, say that that's 1.5. It's up to you, however you want to state it. Okay. Oh my gosh, I skipped the vertical asymptote. Let me go back. My bad. So I want to find the vertical asymptote. Vertical asymptote is to set what's left in that denominator. So I see that 2x plus 3. I'm going to set that equal to 0. I'm going to solve it. So x is equal to negative 3 over 2. Same thing as I talked about in your horizontal asymptote. If you want to say that that is a negative 1.5, go ahead. It's up to you. Because the whole idea is that I can get this when I graph. So let's go graph. So I've got an ordered pair at negative 1, 0. I've got an ordered pair at 0, 1. I've got a vertical asymptote, so a vertical dashed line at negative 3 over 2 or negative 1.5. And I've got a horizontal asymptote at 1.5 or 3 over 2, whatever. Oh, kind of went up a little bit. Okay. So now we're going to play the old connect the dots. So as I connect these two dots, it's going to level off to the right. And it's going to go down towards that negative 1.5. Again, I don't have enough points, so I'm going to pick some random points. So I'm going to go ahead and come over here. I'm going to pick negative 3. So I'm going to plug in a negative 3 here. So I'm going to end up with a negative 6 over a negative 3, which is going to give me 2. So I'm going to have the ordered pair negative 3, 2 to go graph. Okay. And let's say that I wanted to pick the point negative 2. So I can plug that in. And it's really whatever points that you want to pick. So I'm going to end up with negative 3 over negative 1. So that's going to give me a 3. So my other ordered pair would be negative 2, 3. So I can go graph that. Negative 2, 3. Again, I have 2 points I can connect the dots with. Connect and they go up towards infinity. Connect and they go flat as I go off to the left. Okay, so there's another example of one of those rational functions graphed. So the last real thing that we want to do is, let's say we want to go backwards. Like, we have the graph and I want to go back and figure out, well, what possible equation did this graph stem from? So the first thing that I want to do, just like when I graphed it, I want to come up with all of the elements. So I want to come up with a vertical asymptote, a horizontal asymptote, an x-intercept, a y-intercept. I don't really need the domain at this point because the domain's not going to help me know what the equation is, okay? So if I look at this first example, I notice I've got a vertical dashed line here, right at that negative 1. So I've got a vertical asymptote at negative 1. I see I've got another vertical dashed line here at 1. Okay. I don't see a horizontal dashed line, but what I do see is that my values are kind of approaching as they go off to infinity here. They're both approaching this asymptote. This axis, which is actually going to be our horizontal asymptote at y equals 0. Okay, so I'm going to look for an x-intercept. The only time that I'm crossing the x-axis is at 0. Same thing for the y. The only time I'm crossing the y-axis is at 0. So I've got all of my elements now, and I want to try to come up with a possible equation. Okay, so remember that the vertical asymptote came from the denominator. Okay, so they were solved. So what that means is, in the denominator, for me to solve and get a negative 1, that means I must have started with a positive 1. To solve and get a positive 1, I must have started with a negative 1. Right, so that's going to be where my vertical asymptotes come into play. All right. Now, I can go ahead and distribute that out. So I'm going to get x squared minus 1 in the denominator. If I'm looking at the numerator, the only thing that's really going to help me out in the numerator is to know that the x-intercept and the y-intercept were both 0. So the way I'm going to get 0 is if I get a 0 in the numerator. What that means is that I need to have only a variable in the numerator. So you're thinking, okay, well, I could have any variable, x squared, x cubed, x to the 4th, x to the 5th, but not so much, because remember, this horizontal asymptote where it says that I'm at 0, that means that the top must have been must have been smaller than the denominator. Remember, that means that n is less than m. So if in the denominator I have an x squared, that means the only possible solution for the numerator must be just a single x. So that when I compare, x is less than x squared. So let's see if now we can write our equation. So my equation is going to look like x in the numerator over that x squared minus 1. That is one possible equation. All right, let's look at our next example. We want to start with the same kind of idea. So I'm going to look for that vertical dashed line at negative 1. Another vertical dashed line at 2. I see a horizontal dashed line there at 1. I'm going to cross the x-axis there at 1 and at 3. So I'm going to have 1, 0, and 3 comma 0. And I'm going to cross the y-axis right there at 1. Okay, so now that we've got all of our elements, let's kind of talk through how that equation is going to look. We're going to work through it. So first, let's talk about just what the vertical asymptote means. That means that if I was going to equal -1, that means I started with an x plus 1. If I was going to equal +2, that means I started with an x minus 2. All right. So now that we have that, I can go ahead and distribute and get the equation, the denominator of my equation, excuse me. So I'm going to get x squared minus x minus 2. So that's going to be my denominator now that I've kind of distributed that out. So now let's look at the horizontal asymptote and our intercepts to kind of help us. So I know that the intercepts come from after I've canceled something and I set it equal to 0, I multiply it by the denominator, it's gone. So really the x-intercept comes from the numerator. So if I have a numerator where the x-intercept is supposed to equal 1, that means it must have come from x minus 1. And if I have an x-intercept where it's 3, that means it must have come from x minus 3. So now let's distribute that out. So I'm going to get x squared minus 4x plus 3. Okay. So now let's see what we really have here. So if I'm looking at this, now what I want to do is I want to say, okay, well, is the horizontal asymptote making sense? The horizontal asymptote means that I'm going to compare the two values. And when I compare them, I'm going to see that they must be equal to each other, the highest exponents. Because if I have a number other than 0, that means that they must have been equal, and I took the numbers in front. So if I look at this, I should have a 1 in front of a 1 there. Okay, so that would give me the equation that I'm looking for, right? So if I'm going to go write my equation now, let me come down here. I'm going to have x squared minus 4x plus 3 over x squared minus x minus 2, right? All right, last one, here we go. I'm going to start again with my vertical asymptotes. Here we have one at -2. Here we have one at 2. Horizontal asymptote, I see here we are at 1. X-intercept should be at 0. Same thing with my y-intercept. All right, so hopefully by now we're pretty good at just identifying the elements of what we have here. So now to go and write my equation, remembering that I'm going to get my vertical asymptotes will come from the denominator. So I'm going to have an x plus a 2 and an x minus a 2. The numerator is going to be where we got that x-intercept from. Oh, wait, let me factor that together. Sorry. I'm going to go ahead and distribute those factors out. So I should get x squared minus 4 in that denominator. Sorry about that. My x-intercept is going to come from the numerator. For me to get 0, that means that I just only have a variable up there. So the question is, well, what variable? Is it squared? Is it cubed? Is it fourth? Is it fifth? So that's going to lead me to my horizontal asymptote. So looking at this horizontal asymptote, seeing that I have a number, that means that n must have equaled m. My highest exponents must have been equal to each other. What that means is if the denominator is x squared, which we've already figured out, that means the numerator must also be x squared. Right? So now we have our equation. It's going to be x squared over x squared minus 4. Okay. So when we are looking at a graph, the first thing that I'm going to do, I'm going to find all of the elements. I typically like to go ahead and start with the vertical asymptote because that goes in the denominator. Then I kind of look to the horizontal asymptote and the x-intercept to kind of help me out figuring out that numerator. All right?